Hello, my name is Nicholas Menzies. I work full-time as a janitor to save up for school in Toronto, Canada, and I'm a competitor in the 2013 International Space Apps Challenge. And I represent Project Lupa, a project created and worked on only by me to solve the deployable greenhouse challenge specifically for Mars. Why I chose this project was fairly simple. A greenhouse on Mars, I firmly believe, is the first step to the human colonization of Mars, and that will be a monumental moment in the history of the cosmos itself. And that is something I want to be a part of with all my heart. And so I designed a greenhouse for Mars for pre-deployment before any astronauts arrive. And what I wanted to focus on was saving costs because it costs so much to send things off the planet. So I wanted to make it viable and agreeable to the public eye. And so what I settled on was a small greenhouse that'll be sent up, and it's half greenhouse, half rover in a way. It'll be mobile, and what is essentially broken down jars inside of a dome with legs. And these legs will have different instruments on them, common to the rovers we use today, as well as some specific ones for Project Lupa's use. So this will allow it to not only start a greenhouse on Mars, but to examine the rocks and the soil and everything from a place we've never been. And the place I chose was Hellas Planetaeus, and I hope I pronounced that right. Now, the depth of Hellas Planetaeus and the atmospheric pressure there makes it mathematically possible that liquid water could exist there. So it's a very interesting place to land. Now, what is essentially the jars inside the dome of my project are filled with water and algae from Antarctica. Hopefully that gives it a bit more guts because Mars can be kind of rough. So this algae, given its perfect breeding environment, doubles its mass every 5 days. So once it's doubled a few times, we'll take an amount of the biomass from this algae and transport it to the surface of Mars, from the surface of Mars, but put it hopefully into the water if it is there. If it's not, then we'll have to drill into the ice and place it there. Now, the dark green of the algae will obviously absorb more sunlight and warmth than the white of the ice. Now, this will lead eventually, I'm hoping, to kickstart the autocatalytic effect on Mars. Absorb more sunlight, we have liquid water at longer intervals at an exponential rate. And hopefully eventually this will lead to the algae being able to reproduce itself on the Martian surface. Once that happens, it'll start to photosynthesize and hopefully create an enclosed ecodome within the Hellas Planetaeus for an amount of time. Now this will create a few things. It'll start the runaway effect for greenhouse gases on Mars, which in turn may have a chance of terraforming the red planet itself. Another thing about it, so this is my first YouTube video. Now once we get to that point, it'll create an incredible landing spot for future astronauts to come and land on Mars, as well as a base of operations. So the red planet is in essence the greenhouse itself. So if there's any questions or you'd like to see pictures of it, there should be links in the description of my project page. It'll link to a Flickr account with some schematics and a map of Mars. I hope you like my project. Thank you for considering me. It's been an honor to participate in this, and I look forward to doing it again. Thank you.